Part C, we've got this integral to deal with. We're integrating from 2 to infinity. Now there's a couple of things we got to watch out for. The denominator is 0 when x is 0 or x is 1. And we're well away from that. We're starting the integral at 2. So the only impropriety here is that upper limit of integration. So we're going to replace that with b. So we're going to integrate from 2 to b, 1 over x natural log x dx, and look at the limit as b goes off to infinity. Now, how do we integrate something like this? It's actually a basic u substitution. If I let u be the natural log of x, then the du, 1 over x dx, is right there waiting for me. So this is really just the integral 1 over u du. So it's the natural log of the absolute value of u plus c. And so this gives me an iterated logarithm. So this is the limit as b goes off to infinity of the natural log of the absolute value of the natural log of x, evaluated from x equals 2 to x equals b. So this is the limit as b goes off to infinity of the natural log. Since b is going to infinity, it's going to be bigger than 1, so its natural log is going to be bigger than 0. So I don't need the absolute values there. So it's the natural log of the natural log of b minus the natural log of the natural log of 2. So as b goes off to infinity, what happens? As b goes off to infinity, the natural log of b goes to infinity, which means the log of b is going to infinity. That's just a constant, and so we get this answer is actually infinity, which means it diverges. Okay, so that's the answer there. Now, a little footnote here. We know that the integral from 2 to infinity of 1 over x to the p power dx will converge as long as p is bigger than 1. So the fact that this diverges tells us sort of in a way how weak the natural log is. If I had x to the 1.0000000000000000001 power, and I integrated 1 over that from 2 to infinity, that would converge because this power is ever so slightly bigger than 1. Here I've already got x to the first power, so if the natural log of x were comparable to any, just the slightest power of x, that would be enough to tip this integral and make it converge, but it doesn't. And we'll see this again and again, that the natural log is, in terms of things, exponentials are more powerful than polynomials, and the polynomials are going to be more powerful than the natural log. So it's just a footnote there on how weak the natural log is compared to other things in the calculus zoo. Anyway, that'll do it for Part C, and that'll do it for Checkpoint Quiz 11.